Greetings everybody. I debated for a while about even making this video because I'm so late to this Anthony Riley Isle of Man party, but it turned out to be a fun data hunt and GIS exercise, so I figured I'd show what I found out at least and make it available to everybody else. And I will give the links in the description of where you can find all this stuff. I went online and found that, to my surprise, the United Kingdom has made a bunch of extremely highly detailed LiDAR elevation studies done in various areas of the UK available, and they're available from this site up here on the address bar. You can enter that and you'll get to this map, and sure enough they had data running along St. Bees and probably over on the Isle of Man as well, but I wasn't as interested in that. Since the question has been, what was Anthony Riley's elevation at the location he was taking his video of the Isle of Man? Because in Google Earth, the elevation, the underlying terrain, is of such low detail that it gives an inaccurate elevation portrayal along the cliff front at St. Bees. But the LiDAR data makes that much less of an issue because it was flown with 50 centimeter accuracy, whereas the stuff underlying Google Earth is typically from the shuttle radar topography mission, and that in many cases is 30 meters accuracy at best, and where there's rapid changes in elevation, such as from sea level out at the ocean or along a beach up cliffs along the shoreline, there can be quite a degree of inaccuracy when there's a rapid climb like that, or in this case a near vertical climb. So I downloaded the tiles here around St. Bees, which in this case was this NX91 tile, and down here on the bottom you can see the data that's available for that location. We've got a LiDAR point cloud, some vertical aerial photography, which again is extremely high detail. I didn't download any of it, but it's 12 centimeter accuracy, or approximately 5 inches, or 4 or 5 inches resolution, which is very quite good. But I was interested in the LiDAR digital terrain model data, and there's several files you can download at 2 meters, at 1 meter, and at 50 centimeter spatial resolution. And St. Bees, as you can see here, was in the southeast quadrant of this NX91 data, so I downloaded this DTM 50 centimeter NX91 southeast.zip file, and you open it up, you get a whole bunch of individual file pieces that I mosaicked together in ArcGIS. And this is the area in ArcGIS with Esri's underlying base map imagery. There's the Isle of Man, and St. Bees is right over here. So if we zoom in on St. Bees, there's the town, and Anthony Riley presumably was making his recording somewhere along this cliff face. Now here is the problem with trying to use the elevations out of Google Earth. This is the resolution of the elevation model that's used in Google Earth. This is the shuttle radar topography mission. 3 arcsecond, I believe. Anyway, it's 30 meter accuracy, 30 meter pixel sizes basically. And I contoured this and threw these contours over, and you can see it's a fairly smooth gradation along the coastline here from this dark area, which is 0. Well, I guess the black would be the lowest area, but and a fairly smooth rise up to 10, 20 meters and beyond. And so when Anthony used Google Earth and said that he was recording at approximately 40, 45 feet, I don't remember exactly, that's probably not a mistake on his part as much as a misunderstanding of how crude the data actually is the elevation data there and how unreliable it is. Which is why I would suggest anybody doing these kinds of filming or recording, just point your camera down at your phone's GPS and get the height data off of that and share with us, rather than, presuming Google Earth is accurate everywhere, because it simply isn't. So if we turn these contours back off, and this time let's turn on the St. B's LiDAR elevation data. Alright, and there we are. That's the St. B's LiDAR that I downloaded from that UK site. Now notice immediately how much more detailed it is, to the point that you can even see here on this grayscale the heights of the buildings individually marked, and the roads and other features. That level of detail is simply invisible on this 30-meter detail. Now I've hill shaded both versions. That's the level of detail you get from the shuttle radar topography mission. Watch when we turn on the hill shaded LiDAR 50 centimeter. Look at the detail in the buildings and along the cliff face. So we can get a very precise reading of the elevation at any of these locations. I mean, even the footpath and fence lines got picked up, and cars in parking lots. And so I created a layer here that shades based on the elevation in increments of 2, 4, 6, 10, 20 meters, etc. So anywhere Anthony was, he was southeast of these buildings, whatever they ended up being. So he was above 20 meters at a minimum, anywhere along there where he was standing. If he was over this far from the buildings, he was above 30 meters. And if we turn the contours on, here are the elevations he would have been standing at given various points. So at a very minimum, if he was along that ridge southeast of those buildings, he had to have been at least 26 meters in elevation. Well, 24 to 26. In some cases, more than 30. If he was at this highest point, he would have been upwards of 33, 34 meters. So that is the value that should be used when looking and using the Metabunk curve calculator to determine what is or is not visible from his location looking across at the Isle of Man. And again, I will make all this available here on a Google Drive. You can download these and view them in Google Earth. It won't quite look the same as this, but I'll get as much in as I can. But I'd like to say thank you to the UK for making this level of data available, because it's been a problem outside of the United States in many cases getting data this detailed for free, because so much of this is usually flown with commercial subcontractors. They charge a fee for the data, but apparently this LiDAR data is available for much of the UK for free download. So this is the Google or the ArcGIS version. I've made this available, what I can at least, in Google Earth. I've made some KMLs, and here's the hill shaded version. It's not as good a resolution, unfortunately, but it's still good enough to see where these cliff faces are and those buildings. And I've also made the contours available that can be viewed in Google Earth as well. Now they're slightly offset from the actual imagery, because I forgot to put a datum shift in, or I didn't geo-reference something properly, but it's within a very short distance of the right place, and it's fairly consistent everywhere. So if you just make a slight adjustment, it's, let's see, maybe 30 feet, 40 feet off. Like I say, but it's consistent everywhere. And you can overlay those contours and see the real elevations. If you click on there, it'll tell you the contour you're looking at, in this case the 30-meter contour. But if you look down in the lower right corner, according to Google Earth, we're only at 48, 49, 50 feet elevation. So in that case, it's off by a long way, by double. So there's those. And for the Isle of Man, I have made available some 10-meter contours that I generated, which are not quite as accurate because they're from the shuttle radar topography mission, which again is much cruder data, but I didn't want to, it would have taken numerous dozens and dozens of downloads to get the entire Isle of Man done the way I did St. Bees. But these contours are at least within the ballpark of being correct. If we click on this one, this is the 200-meter contour that I generated, and Google Earth's elevation is 685 feet. So it's plus or minus a very small amount different from theirs. Here's the 100-meter contour, and Google Earth says our eye elevation in the corner, or our pointer elevation, is 323 feet. So pretty darn close. The other Isle of Man feature I created was I geo-referenced this map that people have been using and made it available as a KMZ as well. And this is kind of an interesting file. It's a zip file on the Google Drive link I'll add in the description below. And it's made up of literally more than 1,000 small image tiles. So when you unzip that file, place it into a folder of its own, and I'm going to put a quick cut in here while I get the right folder. Alright, so when you unzip this, make sure you unzip it into an empty folder, and it's going to be 1,474 in this case, individual files, individual KMZ files, and what those are is those are the tile views at various zoom levels in Google Earth, so it can draw quickly regardless of what zoom level you're at. You want to click on this, in this case, Geo-ref Isle of Man root.kml file, and that will bring this image into Google Earth. And it's, I geo-referenced it as close as I can get it. It should be pretty much spot on everywhere. And if you overlay my contours on top and compare them with the contours that were surveyed officially, you can see in many cases they're pretty darn close. They're off here and there by a little bit, especially if there's areas of rapidly changing topography. But you know, my 380-meter contour is pretty close to their 380, 360, 370, 360, 350 here. The other useful thing I found with this is, if you've watched my previous video of how to change the field of view in Google Earth, if you click on one of those and come back over here to the Isle of Man, we come over here to St. Bees with a 10-degree field of view and position ourselves somewhat in the area that Anthony was at. There's the Isle of Man with that image overlay turned on. And that headland there should look somewhat familiar from the Anthony Riley, the panoramic footage that people had made in the past. We can fade out this map or in, depending on what you want to see. You can see the features line up, the dark forested areas there. And this has been the area in question. Is this more of the Isle of Man or isn't it? And well, it's sure part of the geo-referenced image, so it looks like it must be part of the Isle of Man to me. It's not Ireland in the background, that's for sure, which disappears completely, especially when you lower the eye altitude there in the bottom right corner. Down to roughly Anthony's eye level. If we were assuming he was at the 30-meter point, somewhere up on that hillside, and we come down here to 100 feet, looks pretty familiar. And those low-lying areas to the east, or excuse me, to the north of the Isle of Man coastline are just another low-lying part of the Isle of Man. So, thank you for watching. Appreciate it. And like I say, I will include a link in the description where I have placed all these geo-referenced maps and contour layers and whatnot, and have at it. Enjoy. And if you have any disagreements with this, or if you have better data, better maps, let me know in the comments and I will be happy to address them. Thank you and have a good afternoon.